Oh, I hate to be the one to tell you this. You are going to spend money on anti-aging this year, and let's be honest about it, most of it will be wasted. So this video is about the small part that actually works, and it starts with a switch inside your cells. And in aging skin, a lot of them are stuck in the off position. Hi, I'm Dr. Linda Brand, a medical doctor with years of experience treating mature skin. In this episode, we're going deep on SIRTUINS, what they are, why they matter for your skin specifically, and what the science actually says about flipping them back on. Chapter 1. What are SIRTUINS? The switches that need fuel. SIRTUINs are a family of 7 proteins. We call them SIRT1 through SIRT7. Easy, right? Each one is an enzyme. Their main job is to walk up to other proteins and pull tiny chemical tags off them. Most of these tags are called acetyl groups. Here's why that matters. Pull the tag off and the target protein changes its behavior. A silenced gene wakes up. A stalled repair crew clocks back in. A stress response calms down. So think of SIRTUINs less like a switch and maybe more like a pit crew. They run around your cell, making fast adjustments, keeping everything tuned. But there is a catch, and it is a big one. SIRTUINs cannot do any of this alone. Every single move they make burns a molecule that we have talked about earlier called NAD+. Full name, nicotinamide adenine dinucleotide. NAD+ is the fuel. No fuel, no pit crew. The SIRTUINs just sit there. Hold on to that idea because it's the whole episode in just one sentence. The switches are only as good as the fuel that runs them. We have 7 SIRTUINs, as I said, 3 neighborhoods. Now, the 7 SIRTUINs do not all live in the same part of the cell. They have addresses. SIRT1 and SIRT2 roam between the cytoplasm and the nucleus. SIRT4 and SIRT5 live in the mitochondria, which are the little powerhouses of the cell. SIRT6 and SIRT7 stay locked to the nucleus, right up against your DNA. And where SIRTUIN lives shapes what it does. A repair crew stationed at the power plant does different work than one stationed at the headquarters. Specifically for skin aging, 3 of them do most of the heavy lifting. SIRT1, SIRT3, and SIRT6. These 3 have the clearest links to how skin ages. They also have the most research behind ways to support them. So those are our 3 main characters. Chapter 2. SIRTUINs in aging skin. The slow fade. Here is a core problem, and it is almost cruel in how simple it is. SIRTUIN activity drops as you get older, and NAD+, the fuel they run on, drops too. Both fall at the same time, and they drag each other down. Less NAD+ means also less SIRTUIN activity. Less SIRTUIN activity means more of the damage that SIRTUINs are supposed to prevent, which actually stresses the cell, which burns even more NAD+. You can see where this goes, right? So how big is the fuel drop? It is not subtle. In human skin, NAD+ falls steadily across your whole life. One study measured skin from newborns all the way to age 77. The trend was clear. The oldest tissue had a fraction of the NAD+ that the youngest tissue had. The number people cite most often is a drop of roughly 40 to 50% from young adulthood to midlife. The exact figure moves around depending on the tissue and the method. The direction is not up for debate. It goes down, reliably, in your skin, SIRT1 and your collagen. Let's make this a bit more personal. Let's talk about firmness. SIRT1 helps keep collagen production on track. It does this by tuning the transcription factors that turn collagen genes on and off. It is basically standing at the mixing board, keeping the levels right. When SIRT1 goes quiet, the board goes out of balance. And one thing in particular starts creeping up. An enzyme called MMP1. And we mentioned it before. MMP1 is a collagen shredder. That is its job. It chews up existing collagen. A little is normal and healthy. Too much and your skin loses structure faster than it can rebuild. Now add sunlight. UV light directly suppresses SIRT1 and your skin cells. So a sunny afternoon does not just damage collagen directly, it also knocks out one of the managers that keeps collagen breakdown in check. SIRT1 goes down, the shredders ramp up, and firmness quietly walks out the door. This is a big part of why sun-damaged skin sags sooner. It is not only about the sun breaking things, it is about the sun switching off the crew that fixes things. SIRT3 and the power plants. Now down to the mitochondria. Your dermal fibroblasts are the workhouse cells of your skin. They pump out collagen, elastin, and hyaluronic acid. Basically everything that makes skin bouncy and plump. And that work is expensive. It needs a lot of energy. And that energy comes from the mitochondria. And SIRT3 is a maintenance sheaf that keeps those mitochondria running clean. When SIRT3 fades, the power plants get sloppy. They start leaking more reactive oxygen species, which are the unstable molecules we covered back in the free radicals episode. This one. More leakage means more oxidative damage, and more damage means more stress. Same loop as before. The result is an aging fibroblast that makes less collagen, spits out more shredders, and slides toward a burnout state called senescence, which we also covered earlier. SIRT3 is one of the reasons your collagen factory slows down with age. SIRT6 and the DNA repair crew. Last of the big three, SIRT6. Every time a skin cell divides, its DNA takes a little damage. Time UV hits it, more damage. Your DNA is under constant low-grade fire, especially the DNA in the cells facing the outside world. SIRT6 is one of the first responders. When DNA breaks, SIRT6 shows up at the scene and helps organize the repair. Think of it as the crew chief who tapes off the area and directs the fix-it teams. As SIRT6 declines, those breaks get repaired slower and less often. Damage piles up, and that pile-up, called economic instability, is linked to both. Chapter 3. What drains the tank? Everybody wants the fuel. Here is a plot twist. SIRTUINS are not the only ones burning NAD+. Two other groups are drinking from the same tank. First, PARP enzymes, which repair DNA breaks. Useful work, but every repair burns NAD+. Second, an enzyme called CD38. And CD38 is the freeloader of this story. CD38 activity climbs as you age and as inflammation rises, and it is a heavy NAD+ consumer. So picture the tank. When you are 25, there is plenty of fuel to go around. PARP, CD38 and your SIRTUINS all get their share. Then fast forward to 55. You have more DNA damage, so PARP is working overtime. You have more inflammation, so CD38 is guzzling. And the tank itself is smaller because NAD+ production has dropped. Guess who gets cut off last in line? The SIRTUINS. The very crew you need most is the one that gets starved first. The stuff you're doing to yourself. Now for the more uncomfortable part. Several everyday things speed all of this up. And most of them are on your daily to-do list without you noticing. You have UV radiation, we covered it. It directly suppresses SIRT1. Sunscreen is a SIRTUIN strategy, and nobody marketed it that way. Chronic stress, sustained stress keeps PARP firing, which keeps draining NAD+. Alcohol, it competes for the same machinery your cells use to build NAD+. So that nightcap is quietly getting in the fuel line. Bad sleep. SIRT1 runs on a daily rhythm, and shortening your sleep blunts it. And a constant stream of rich calorie-dense food, it shifts your cell's chemistry in a way that leaves less usable fuel for SIRTUINS. If you're looking at that list thinking it describes a normal modern week, yeah, this is kind of the point. Chapter 4. What actually helps? Okay, enough doom. Let's talk about what you can actually do. There are 4 real strategies. Some have strong evidence, some are promising but early. Let's start with strategy number 1. The most direct move is to give your cells more raw material to make NAD+. The two big ones are NMN and NR. NMN is nicotinamide mononucleotide, NR is nicotinamide riboside. Both get converted into NAD+ inside your cells by slightly different routes. Human trials show these can raise NAD+ in the body. So strategy 1, refill the tank. The Avia Life's NMN can help with that. It's an oral NMN supplement that uses a 99% pure form called Longevir, and their own guidance is 250 to 500 milligrams a day. That sits right within the range used in human trials. Strategy 2. Stop the freeloader. Remember CD38, the enzyme guzzling your NAD+? What if you could tell it to slow down? It turns out that some plant compounds do actually that. Apigenin, a flavonoid found in parsley, celery, and chamomile, blocks CD38 in cell and animal studies. Quercetin, we have talked about this one before, found in onions, apples, and capers, does something similar. The logic is clean. Slow the freeloader and more fuel is left for the SIRTUINS. It is a supply and demand fix rather than just pouring in more supply. Strategy 3. Poke SIRT1 directly. Resveratrol is a compound in red wine that, back in the day, was shown to activate SIRT1 in a test tube. Cue a decade of headlines about wine being the fountain of youth. Then it got messy. Other scientists found the original activation might have been an artifact of the lab assay, not the real effect. Big fight in the field. Eventually, a 2013 study sorted it out. It showed that these SIRT1 activating compounds called stacks really can switch SIRT1 on, but only for certain targets and through a very specific mechanism. So resveratrol is real, just far more finicky than the hype suggested. Now, here's a bonus you might already own. Retinoids, tretinoin and its cousins. They nudge SIRT1 up indirectly, on top of everything else they do. It is one more reason that retinoids hit so many aging targets at once. Strategies 2 and 3, plug the drain and flip the switch. Both live in the Avia Life's booster. It carries 50 milligrams of apigenin to slow CD38, plus 150 milligrams of resveratrol and a dose of pterostilbene. Pterostilbene is basically resveratrol with a better passport into your cells. And it comes in an oil base, which actually matters because, remember, these compounds are notoriously hard to absorb. And the senescence angle, the worn-out zombie cells we touched on with SIRT3, that is the Avia Life's cell primer. It packs 500 milligrams of quercetin in a phospholipid form that absorbs far better than a raw stuff, plus fisetin and spermidine. Strategy 4, the one that is free. Here is the strategy with the deepest evidence base across the entire animal kingdom, and it costs $0. And it is eating less, specifically caloric restriction, and its more livable cousin, intermittent fasting. Go through a fasting window, NAD+ rises, and SIRT1 activity goes up through several pathways at once. This is one of the most reliable SIRTUIN levers we know of, and unlike a fancy supplement, it has been studied for decades. The catch, however, and you knew there would be one, is that the specific payoff for skin aging has not been nailed down in careful human trials yet. So I am not going to promise you that skipping breakfast erases wrinkles. But of everything on this list, fasting has the strongest and longest track record for actually moving SIRTUINs. It just asks something of you in return. So here is my honest take. The products from Avia Life are well formulated. The doses are real, and the ingredients genuinely match the mechanisms we covered. Chapter 5, Myth Busting. Now, let me save you some money. 3 myths that need to die. Myth number 1. Red wine is a SIRTUIN plan. Oh, I hate to be the one to tell you this. The resveratrol in red wine is present in tiny amounts, micrograms. The studies used doses thousands of times higher. To drink your way to a researched dose, you would need something like hundreds of glasses. At that point, the alcohol is not just failing to help your SIRTUINS, it is actively damaging them. Myth number 2. More NAD+ automatically means better SIRTUINS. Oh, if only. Flooding your blood with NAD+ precursors does raise circulating NAD+. But getting that fuel into the right compartment of the right cell and having the SIRTUINS machinery in good enough shape to use it is a whole separate problem. Fuel helps. Fuel is not the entire engine. More is not automatically better. Myth number 3. SIRTUINS are longevity genes. You will see them call that consistently. It is kind of misleading. SIRTUINS are not genes that set your lifespan like a timer. They are responders. They react to your metabolic state and adjust. Their link to living longer is real but tangled. Chapter 6. SIRTUINS are real. So let's land this plane. What do we actually know? We know SIRTUINS are real. We know they matter for skin aging, and we know their activity falls with age, largely because their fuel, NAD+, also falls with age. So that part is solid ground. We also have real tools to support them. NAD+ precursors, CD38 inhibitors like apigenin, quick restriction and fasting, plus the boring heroes, sleep, exercise and sunscreen. For several of these, the evidence is generally strong. If I had to leave you with one line, it is this. You cannot buy your SIRTUINS back into their 20s, but you can stop draining them so hard. Protect the fuel, ease off the freeloaders, and let the pit crew do its job. Next episode, we go somewhere even deeper. Inside the stem cells that rebuild your skin from the ground up. You are definitely going to want that one. If this helped something, click, subscribe and drop a comment. Tell me which part of skin aging you most want us to unpack next. And I'll see you in the next one. Bye!